Hello everyone, I am Dr. Mohd Nasim, Assistant Professor, Civil Engineering Department. So today we are going to see in our BTech, we are going to do the concrete mixing in our second year. And in MTech also we have seen the advanced concrete technology. In that we have seen the concrete design is also very important. For BTech pass out student also, this topic is very useful, and for the civil engineer who has worked outside the in field also, they are doing the concrete mixing. So basically concrete mix design, when in 1982 first concrete mix design IS Indian Standard Code was published. So when it was published, after that second edition, after first revision, it was published in 2009, and the latest revision it was came in 2019, which is also the updation of the after the 2009. So in our concrete mix design, so concrete mix design is basically it's an art of selecting the ingredient which is required for the concrete in a suitable proportion. Our aim is to get the minimum strength and its durability to get the proper mix. So basically what are the objectives of mix design? Mix design objective is to get a desired workability at the plastic stage and to get the desired strength at the hardened state. So in our concrete we have only two stages, plastic stages and the hardened stage. So in our plastic stage, our main aim is to get the workability. So desired workability is very important in our concrete mix design. Or in plastic hardened state, the strength is very important. After strength, durability point of view of durability property is also very important to achieve desired durability in a given environmental condition. Or next thing is to get the concrete as economically as possible. So we have to make the concrete economical. Not if you are using more cement, the cost of concrete will increase. So we have to see whether the concrete is making economical or not. So these are the four objectives. We have to ensure the optimal proportion of the constructed materials. So these are some basic consideration while designing the concrete mix. So first condition is cost. What is the cost of the concrete? Second is the specification. What are the specifications of the concrete? Third one is the workability. So in plastic stage, the workability is very important. So that property is very important. Then the strength and durability of the hardened concrete. So cost. So basically the cost of the concrete is comprises of three: material cost, and equipment cost, and the labor cost. So in material cost, we have seen the cement is very costly, so we have to use cement very lean. So because the cement cost is very costly as compared to the other constituent of the concrete, such as coarse aggregate, fine aggregate, and other materials. So therefore all possible steps should be taken to reduce the cement content of a concrete mix without sacrificing the desired properties of the concrete, such as strength and durability properties. So we have to see the material cost. Then equipment cost also very important. We have to use the proper equipment for the testing of the concrete. Labor cost also included in the design of the concrete. Then these are some following point that may have to kept on while designing the concrete mix. So first is the minimum composite strength is very important. So just like if you are designing for M20, so M20 strength should be come. otherwise our concrete is not come in the process. So next point is the minimum water cement ratio. So minimum water cement ratio also very important. We have to see the in which condition what water cement ratio is required. We have to make that water cement ratio concrete. Then the maximum cement content also very important. As per IS 456, we have to see the maximum cement content, and that standard we have seen the maximum cement content. Then maximum aggregate cement ratio. Then maximum density of concrete in the case of gravity dense is very important. So these are the some points we have to keep in our mind while designing the design of concrete mix. Then the workability. Workability is very important aspect, because in these are the some workability related point while designing the concrete mix. First is the consistency of the concrete should not be more than that necessary for placing, compacting and finishing. For concrete mix required high consistency at a time of placing. So use of water is reducing admixture, and set retarding admixture should be used rather than addition of more concrete, more water. If you are using more water, then our concrete will have the less strength. So without using more water, we have to use the admixtures which has the water resisting admixtures and the set retarded admixtures. So then next consideration is strength and durability. So strength and durability, how can you achieve? By using the lower the water cement ratio, not increase the cement content, but we have to see the water content should be important. So water cement ratio is very important in the case of strength and durability. So in the case of workability, we can see the when we increase the water, the workability also increase, but the strength is decreased. So we have to see the water cement ratio is very important in the case of strength and durability. So by lowering the water content at the given cement content, we can improve the our strength and durability properties. So water demand can be lowered by throughout the control of the aggregate grading and by using the water reducing admixtures. So in concrete mix design, we basically seen two types of concretes. First is nominal concrete mix, and second one is the design concrete mix. So when we go for fixed proportion of the concrete mix, the nominal mix is there. So when you use the mix of fixed proportion, just like we have M15 grade of concrete, we have fixed proportion of proportions of concrete. M20 we have fixed proportion. So this mix is called the nominal mix, in which the proportion of the ingredients are fixed. So the nominal can be used for M5, M7, M10, M15, M20. So these are some grades of concrete is the mix are fixed, a proportion are fixed. Just like M5 you have seen 1:5:10, M7.5 1:4:8, M10 is 1:3:6, and M15 1:4, and M20 1:1.5:3. So these are the some nominal mix in which the proportion of the ingredient is fixed. Then design mixed concrete. In design mixed concrete, we have to make the concrete as the requirement of the concrete. So in design mixed concrete is being used for more and more in variety of the important structures, because of better strength, reduced variability, lean mixed and subsequent economy, as well as of greater resultant quality. So design is very important. So these are the some factors in which we can in which these factors can influence the design mix. So first one is the grade of concrete. So grade of concrete also very important, which type of grade you are using Type of cement also is very important. Which type of cement you are using, PPC, OPC, then other type of cement also there, which type of cement required, then maximum nominal size of aggregate also. So which type of aggregate size is used, either you use less than 20 mm or greater than 20 mm as per the requirement of the condition. Second, the grading of the combined aggregate. So grading of aggregate is also very important. If you are using single size aggregate, our packing density of concrete is not good. So for get the packing density of the concrete, we have to use the graded concrete. Then the maximum water cement ratio is very important. We have to see in which exposure condition what are the maximum water cement ratio is given in the IS codes. So that thing you will get in the IS 456 code. Then workability also is very important, durability and the quality control. So these are the some factors which can influence the concrete mix design. Then first one is the grade. As we discussed about the grade of the concrete, basically grade of concrete gives the characteristics of the strength of the concrete, and this is an important factor which influence the mix design. So the grade M20 denotes characteristic strength of 20 Newton per mm, which is M is a mix and 20 is a characteristics composite strength at the 28 days. So depending upon degree of control available at site, the concrete is designed for the target mean strength FCK dash for standard deviation. So this is the grade of the concrete for all the groups, for lean mix, ordinary concrete, standard concrete, and for high strength concrete also. So you have seen that from M5 to M25 we have a fixed proportion of the concrete because these mix are the nominal mix. Then after 25 we have to do the design mix for get the subsequent characteristic composite strength. Then next factor is the cement. Cement also is very important. So which type of cement you are using, which grade of the cement are you using, that also very important in the concrete. So to get the highest strength cement in the concrete should be use of 43 grade or 53 grade, which gives the best results for the M25 grade of concrete. If you are using less than 25 grade of concrete, you can use the use of 33 grade of concrete or other concrete. So next factor is maximum nominal size of aggregate. So maximum nominal size aggregate, we have to see the what type of nominal size of aggregate we have to use on our concrete. Just like if you are going to make high strength concrete, so your grading maximum size of aggregate should not be more than 20 mm. If you are using more aggregate size of aggregate, you will get the lesser strength. So to get the highest strength, you have to use the less than 20 mm aggregate size. So it is very important. So last point is the workability of concrete increase with the increase of the maximum aggregate size of it, but smaller size provide the larger surface area for the bonding, which gives the highest strength. So it is very important point. To get the highest strength, we have to use the lesser size of aggregates. Then the grading of combined aggregates. So in earlier also I have said that we have to use the graded aggregates, well graded aggregate, because if we are using single size of aggregate, the packing density is very low. So to get higher packing density, we have to use the well graded aggregate to get the highest strength. Then the maximum water cement ratio. So as per Abraham's water cement ratio law, it states that for any given condition of test, the strength of workability concrete mix is dependent only on water cement ratio. The lower the water cement ratio, the greater is the compressive strength. Next is workability. So workability also I have explained. It is a ease with which concrete can be mixed, transported, placed and finished without harmful segregation and bleeding. So we have to see whether our concrete is without segregate or bleeding. So that thing also we have to consider in our concrete mix design. Next, the durability. Durability is very important, and it will get using the lower water cement ratio, because if you are using the higher water cement ratio, the strength also decrease and the durability properties also decrease due to the water particles in the constituent of the concrete. So we have to use the lower water cement ratio to get the higher durability. So these are the some concrete mix design method from which we can design our concrete mix, just like IS method. In our India we have used IS method, ACI method, road node 4 method which is used in UK, IRC 44 method, arbitrary method, maximum density method, fineness modulus method, surface area method. Next, mix design for high strength concrete, mix design for pumpable concrete, and DOE method for the British. It is a British mix design method. So basically these are the some introduction regarding the concrete mix design. So after that we will see the which type of we are using IS codes. So from IS 102-262 1982 to 2019 we will see the all three codes and what are the changes they have made in first revision and second revision. We will see in next lecture. So thank you. Hello everyone. So in previous lecture we have seen the introduction of the concrete mix design. In that we have seen the what are the concrete mix and what are the basic consideration for designing the concrete mix and what are the factors which influence the concrete mix. So in previous lecture we discussed these things, and in this lecture I will explain the Indian standard codes which is used for the concrete mix design. So in latest we have a code of 10262-2019, but before going in that code we will see the previous version of code, which is that code is published in 1982. So this is basically the recommended guidelines for the concrete mix design. In that some definition was there. So in 0.3 we have seen the proportioning of concrete mixes consist of determining of the quantities of respective ingredients necessary to produce concrete having adequate but not excessive workability and strength for a particular loading and durability of concrete for exposure to which it will subjected. So our main emphasis is given in that code is to make the concrete most economical use of available materials, so as to produce concrete of a required attributes at minimum cost. So required attributes mean required properties of the concrete at minimum cost. So basically this definition is given in IS 10262-1982. So proportioning of concrete we have seen, we have get at minimum cost we have to make the concrete and economical use of available material. So then second, the concrete has to be satisfactory quality in both the fresh and hardened state. So our task of proportioning the concrete mix is accomplished by the use of certain established relationship which afford reasonably accurate guidance for selecting the combination of ingredient so as to achieve the desired properties of the fresh and hardened concrete. So their overall is that mix design is generally carried out for a particular composite strength of the concrete coupled with adequate workability. so that the fresh concrete can be properly placed and compacted. So in addition, mixed proportion are also checked against the requirement of the adequate durability for the type of exposure condition anticipated in service. So in this clause we have seen the compressive strength is very important. Our main emphasis is in that clause is seen that they are saying the compressive strength is very important. We have to select the best combination of ingredient to get the desired compressive strength of the concrete. So next point, they are giving the assumptions to get the mixed design is that the compressive strength of workable concrete is by and large governed by the water cement ratio. So in that clause they are saying that your concrete mixed design is to get the compressive strength. So compressive strength is directly proportional to the water cement ratio. So it is very important relationship about the water cement ratio and the compressive strength in clause number 5th. And then these are the some stress for designing the. So basically these are the some definitions which are given in the 1982 code. Then in next code we will see the. So this is the first revision of that code 10262/2009. In that we have seen the title of the code is different as we have seen in other code, previous code. So this standard was first published in 1982. In this revision, these are the following modification they have made. First one is the title of the standard has been modified as concrete mix proportioning guidelines. From the earlier title it was recommended guidelines for concrete mix design. Second point, the applicability of standard has been specified for ordinary and standard concrete grades only. So in previous code we have not seen the word standard and the ordinary. They have seen directly the concrete mix design. So in that we have seen the ordinary and standard grade of concrete. So third, various requirements have been modified in the line of requirement of IS 456. So in previous code it was line with IS 456 1978. So the after IS 456 2000 this code has been modified as per the 2000 code, which is code of practice for the reinforced plain and reinforced concrete. Then fourth point is the requirement of selection of water cement ratio, water content and estimation of coarse aggregate content and fine aggregate content have been reviewed and accordingly modified. And similarly other requirements such as trials, mixes and some more example also reviewed in this section. Then fifth point is a new example of concrete mix design using fly ash as one of the ingredients has been added. So after IS 456 2000 there are some other admissions also included in the standard, just like fly ash, GGBS, metacoilin, silica fuming. So in this standard we will see the example of mixed concrete mix design using the fly ash also. So and then last point, the considering the air content in normal concrete is not much significance in mixed proportioning procedure, which is not part of IS 456. So in our previous standard in 1982, in that the air content is included in the concrete mix design process, but in this they have deleted this air content consideration in the concrete. So basically these are the references they have taken by the other codes, just like I-8 383 1970, 456 2000, 2386 part 3, 3112 part 1 2003, 8112 1989, 9103 199. So these are the some references they had taken to get the this code. So we will see next code new code is IS 102.262 2019. It is a second revision of the mixed design, concrete mixed design standard. It was first published in 1982, then in 2009, then latest version it was published is 2019. The title is same as we have seen in 2009 code, but in this they have do the major modification in this codes. So these codes are divided into 5 sections. So first section is general section, second is ordinary and standard grades of concrete, third section is high strength grade of concrete, fourth section is self compacting concrete, and fifth section is mass concrete. So these are the 5 sections. In that they have given so many examples also, from ordinary concrete to mass concrete. So basically this standard was published in 1982 and subsequently revised in 2009, and in first revision the title of the standard was modified from recommended guidelines of concrete mix design to concrete mix design proportioning guidelines. So in first revision the major changes was restricting the applicability of standard to the ordinary grade of concrete, alignment of standard of IS 456 2000, plain and cement, plain and reinforced concrete, practice code of practice. Then in second point, first point is they have divided the IS code into 5 sections, just like we have seen the general, ordinary and standard grade of concrete, high strength grade of concrete, self compacting concrete and mass concrete. Then second point is the mixed proportioning procedure for high strength concrete for M65 or above, up to the target of strength of M100 has been included. So in previous code we will see only the M55, up to M55 they are given, but in that code we will see the above M55, which is M65 and up to M100. Then third point is the initial data to be provided for mixed proportioning has been made more encompassing, covering the provision of revised IS 383 2016 coarse and fine aggregate for concrete, third revision, use of admixture. So in previous concrete mix design code they are using the IS 383 1978, but in the latest version they are using the IS 383 2016 code. Then fourth point is the target mean strength for mixed proportioning formula has been redefined to include the new factor based on the grade of concrete. So this has been done to ensure the minimum margin between the characteristic composite strength and the target mean composite strength. Then next point, the calculation for standard deviation has have been detailed. In that we will see the formulas of standard deviation for one group or multiple groups also. Then next point is graph of water cement ratio versus 28-day strength of concrete has been introduced for different grades of concrete, types of cement, and alternate method for assuming the initial water cement ratio. So in our previous code there is no graph for the water cement ratio for getting the strength. So in that they have included the graph of water cement ratio versus the strength. Then next point, they have given the examples for the mixed proportioning of PPC, OPC with fly ash, OPC with GGBS, high strength concrete, self compacting concrete and mass concrete also included in the code. Next point is guideline of using water reducing admixture has been introduced as a informally. Matlab, in that we will see the guidelines of selecting water reducing admixture. Next, the consideration of air content in design of normal concrete mixed proportion has been introduced. So in first revision we will not see the air content design, but in third revision we will see the inclusion of air content in the concrete design. So this is the section number 1, journal. So basically we will see that these are the references We have seen in previous, we have seen the IS 383 1978. We will see here we will use the latest version of all the codes. Here updated is 383 2016. IS 45 is same, and other parts also included for the designing of the concrete. Then terminology, these are the some terminology. We have given water cement ratio and water cementesis ratio, and these are the some mixed proportional datas, which data is required to design the concrete. First one is grade designation, then type of cement, grade of concrete, grade of cement, just like OPC. If you are using OPC, just like 33 grade, 43 grade and 53 grade is applicable. Then maximum nominal size of aggregate, just like we have seen in our previous lecture, we discussed about the maximum nominal size of aggregate. Then minimum cement content and cementitious material, maximum water cementitious material ratio to be adopted. Then that thing is given in table number 3 and table number 4 of IS 450 2000. Then workability required for time of placement, then transportation time, method of placing, then degree of site of control, which type degree we are using, good or fair, then type of coarse aggregate, angular, subangular, gravel with some crust particles, grounded gravel, manufacture coarse aggregates, then type of fine aggregate, then maximum cement content, whether a chemical admixture shall be used or not used in the concrete, whether a mineral admixture shall be used or not in the concrete, and any other specific requirement like early age strength requirement. So these are the some data which we'll use in the early age of the early starting of the concrete designing. Then next in we will see the target strength for mixed proportioning. In order that not more than the specified proportion of test results are likely to fall below the characteristic strength, the concrete mix has to be proportional for higher target mean composite strength FCK dash. The margin overall consistency is given by the following relation. So in previous IS code we have seen only the one relation, which is FCK dash plus FCK plus 1.65 S. But in this code they are giving one more relation, FCK dash is equal to FCK plus X. X is nothing but a factor based on the grade of concrete, which is given in the table number 1, and FCK dash is equal to FCK plus 1.65 S. So basically 1.65 is a coefficient which describe the maximum 5% is likely to fall when you are using the group of test. So basically 1.65 is a 95 confidence level of the method. Then standard deviation, in starting they have in this section we will see they are giving the to get standard deviation formula to get the strength of the samples. So standard deviation based on the strength of the samples. So number of test samples should be not less than 30, it should be greater than 30. So minimum number of samples should be 30 for the standard deviation. So these are the some formulas to calculate the standard deviation. First is for single group of test results, and for second is a two group of consecutive test results. It is a formula for the standard deviation. Then this table number 1, the value of X is given for the from M10 to M60, and above M60 also given. So M10 and M15 the value of X is 5, then M20 to 25 the value of X is 5.5, from M30 to M60 the value is 6.5, and above M65 and above is 8. So basically the M10 and 15 is a ordinary concrete, then standard concrete, then M30 to M60 is high strength concrete, and M60 is high strength concrete. This is the assumed standard deviation for the characteristics composite strength. When you are calculating the target mean strength, these are the some assumed standard deviation for the different types of mix. For M10 to M15 3.5, M20 to M25 4, M30 to M65, and above M65 above M60 M65 to M80 is 6. So these are the some standard deviation values to calculate the target mean strength. Then section number 2, ordinary and standard grade of concrete. So in this we will see the selection of mixed proportion. The first portion is selection of water cement ratio. So how much water is required to get the good proportion of the concrete. So in this, different cement and supplementary cement of material and aggregate of different maximum size, grading, surface textures, shape and other characteristics may produce concrete of different composite strength for same free water cement ratio. Therefore, relationship between strength and free water cement ratio should be preferably established for the materials actually to be used. In absence of such data, the preliminary free water cement ratio by mass corresponding to the composite strength at 28 days may be selected from the relationship shown in figure 1 for expected 28 day strength. So the final water cement is arrived at the results of trial, and any changes in strength of cement shall be adjusted in the trials. So where supplementary cement and materials are used, just like mineral and mixtures, water cementitious materials shall be calculated in accordance to table number 5 in IS 456. Then 5.2 is estimation of air content. Then estimation of air content in previous code, this estimation of air content is deleted, but in that code they have included the air content. So for maximum nominal size of aggregate for 10 mm, the entrapped air is 1.5, for 20 mm is 1, and for 40 mm this is 0.8. So this is graph for the composite strength versus the water cement ratio for the 33, 43, 53 grade of OPC concrete. Basically this graph is for given in only the OPC graphs, OPC grade of concrete, but if you are calculating the PPC grade of concrete, other concrete grade, you have to use that graph also for the free water cement ratio. Then selection of water content and admixture. The water content of concrete is influenced by the number of factors such as aggregate size, aggregate shape, aggregate texture, workability and water cement ratio, and other supplementary cementous material, and chemical admixtures and environmental condition also. So when we increase the aggregate size, the reduction in water cement ratio and slump, and use of rounded aggregate and water reducing admixture will reduce the water demand. So this is the water content for the maximum nominal size of aggregate when we use in our concrete mixing. So for maximum nominal size aggregate for 10 mm we will use 200 kg, for 20 is 186, and for 40 mm is 165 kg per meter cube. Then the calculation of cementitious materials content. In this the cement and supplementary cementous material content per unit volume of concrete may be calculated from the water cement ratio and the quantity of water per unit volume of the concrete. In certain situation, when we use the replacement, just like replacement of cement by the fly ash, GGBS, silica fume and other mineral admixture, increase in cementous material may be warranted, particularly if fly ash is 20% or more. So for the cementitious material we will use the IS4 sizes for the specified amount of the cementitious material. Then next point is estimation of aggregate proportion. For aggregate proportion, proportion is in table number 4, just like we have seen in table number 5, volume of coarse aggregate per unit of total aggregate for different zones of fine aggregate for water cement ratio materials of the 0.5. So this table is for 0.5 water cement ratio for the different zones of the fine aggregate. Just like in first column, maximum nominal size of aggregate is 10 mm, 20 mm and 40 mm. So different zones are there. So when you calculate, when you do the fine analysis of CO analysis of fine aggregate, you will get the zones from IS 383 2016. You will get the zones in which zone your concrete, your fine aggregate is coming. So from that you will calculate the volume of coarse aggregate. Just like if you are using the 20 mm aggregate and your zone is 2, so 0.62 value is your volume of coarse aggregate. Then after that we will calculate the estimation of fine aggregate and coarse aggregate. Then next section is high strength concrete. In first section we will see the general section, and second section is we will see the ordinary and standard concrete. Third section is we will see the high strength grade of concrete from N65 to and above up to 100. In that we have to use the different cementitious material also, just like fly ash, GGBS, silica fume and metacoulin also used in the concrete. The coarse aggregate for the high strength concrete should be less than 20 mm. For getting higher strength we have to use the 10 mm grade of concrete only. So for high strength grade of concrete, the fine aggregate also should be required as per the IS 383. Then for a high strength concrete we have to use the chemical admixture also to get the highest strength. Then designing of concrete for higher strength, these are the some steps. These are the same steps as the standard and ordinary concrete, but these are the some modification in the table. Just like estimation of air content, the for 10 mm, 20 mm, 12.5 or 20 mm, the entrapped air volume of is changed as we have seen the standard and concrete. Selection of water content and admixture content. It is water content per cubic meter for the nominal maximum size. For 10 mm it's 200 kg per meter cube. For 12.5 mm it's 195. For 20 mm is 186 kg per meter cube. And this is recommended water cement ratio for the high strength concrete with higher reducing admixtures. These are the some composite strength, just like 70 composite strength. These are the nominal maximum size of aggregate 10 mm, 12.5 and 20 mm. Then these are the some recommended doses of the mineral admixtures material for high strength mixes. For fly ash, the recommended dose is 15 to 30. Then GGBS is 25 to 50%, metacoulin is 5 to 15%, in 4 silica fume 5 to 10%. So these are the some recommended doses and what percentage we have to use in our concrete. So we are saying that the fly ash we can use only the 15 to 30%, and GGBS 25 to 50%, metacoulin up to 15% and silica fume up to 10% only. Then volume of coarse aggregate as for different zones of fine aggregate for water cement ratio of 0.3. So this is table for 0.3, but in previous section for ordinary concrete for water cement ratio is 0.4. So here water cement ratio and water cementation ratio material is 0.3 only. So according to that the volume of coarse aggregate can be defined for the different zone of fine aggregate. In that zone 1, zone 2 and zone 3 is given. Next section is self-compacting concrete. So in this lecture we will not cover this self-compacting concrete, and for mass concrete also we will not cover. In next lecture we will cover these two sections. So let's we take the example which is given in that code for the concrete mix and proportioning. So it is the first example for M40 grade. These are the some Data is given for grade M40, type of cement is PPC, maximum nominal size is 20 mm, maximum cement content and maximum water cement ratio to be adopted, or exposure condition as per table 3 and table 5 of IS4 sizes. So here is severe condition is given for the reinforced concrete. So this thing we will see the IS4 sizes for the minimum cement content and maximum water cement ratio. Next point is workability. In workability, in that workability is 75 mm slump. So in that slump is given is 75. Then method of control is shoot method. They are using the shoot method. They are not pumpable method. They are using a shoot. The design, so degree of side control is very good, and type of aggregate is crushed angular aggregate. So in all codes they are using the type of aggregate crushed angular aggregate. Basically all the tests are for the crushed angular aggregate. So if you are having some other aggregate, according to that you have to change the data. So then maximum cement content, which is not including the fly ash. So our maximum cement content should be 450 kg per meter cube for cement only. Then cement admixture, they are using the normal superplastizer admixture. Then test data for the materials. So cement PPC is confirmed, specific gravity of PPC is 2.88, chemical admixture is superplastizer, specific gravity of coarse aggregate is 2.74 and fine aggregate is 2.65 for SDD condition. So what is SDD condition? Basically SDD is saturated dry condition, surface dry condition. So saturated means no water is absorbed, and SD surface dry means no moisture content is present. So these are the results for the saturated surface dry condition for fine aggregate and the coarse aggregate. The chemical admixture also specific gravity is given 1.145. Water absorption for coarse aggregate and fine aggregate is 0.5 and 1%. Moisture content of aggregate as per IS 283 part 3, which is nil. In that they are not given any moisture content. Then it is CO analysis. They are confirming June 2nd as per the CO analysis of fine aggregate of IS 83. So these are the some test results of the materials which we have taken in our designing. Next, the designing. The first is target strength of the mix. So we have already discussed FCK dash is equal to FCK plus 1.65 S or FCK dash is equal to FCK plus X. So these are the two relation and which provide the target strength of the concrete. So from table 2 we have seen the standard deviation for M40 grade is 5. So when we see the standard deviation table, this is here given the for M40 the standard deviation is given 5 Newton per mm square. For M32 and 60, so our concrete is M40, so that's why we have taken the 5 for the standard deviation. Next, for second is FCK plus X. X for M40 X is given 6.5. So whichever is higher value we have to adopt. So is the higher value is first relation. From first relation it is 48.25 Newton per mm square. So therefore target strength will be is 48.25 Newton per mm square. Then second point is experiment air content. So here is for 20 mm nominal of aggregate the percentage is 1. It is given in the clause. Then selection of water cement ratio. From figure 1 we have seen we have a graph. From that we will get the water cement ratio by target strength. So in our graph, this is the graph, and our target distance is 48. So 48 will our we have to see the curve 2 for the 43 grade of concrete, because we have to design the M40. So we will expect the 43 grade concrete. So it will come in 0.36 to 0.4. It will come in the 0.36 to 0.4. So according to, we have to adjust, and on the basis of graph we will calculate the free water cement ratio. So from table 3, from figure 1, free water cement is required for target strength is 0.36 for OPC 3 grade of concrete. So for PPC strength corresponding to OPC 43 grade of as assumed for the trial. So in this question they are taking the OPC 43 grade of concrete as a PPC. So this is lower the maximum water cement ratio as per table number 5 as IS 456. So our 0.36 is less than the 0.4, so we can use lesser the maximum water cement ratio. So it hence okay. Then selection of water content. So from table 4, the water content for 50 mm slump for 20 minutes 186. So but our slump is 75 mm. So every 25 increase in mm we have to increase the 3%. So 186 plus 3 into 186 divided by 100, we will get the 191.95 kg of water content. So we are using superplasticizer also. So according to that we have to reduce the water content. So based on trial, the water content reduction of 23% is considerable while using the superplasticizer at 1% of by weight. So according this relation, we can get the actual water content, which is the 148 kg of water. Then next point is calculation of cement content. So we have water cement ratio and we also calculated the cement content. So from that relation we will calculate the water cement ratio. We will get the cement content of 412 kg per meter cube, so which is also less than the minimum cement content for the cement is 320. So our cement content is more than 320 kg meter cube. So it is also good as per our requirement. Next is proportion of volume of coarse aggregate and fine aggregate. So just like we have do the fine aggregate analysis, we have seen our fine aggregate come in zones 2. So for zone 2 the coarse aggregate proportion is 0.62 for 0.5 water cement ratio, but we have a 0.36 water cement ratio. So we have to do the interpolation for coarse aggregate proportion. So as the water cement ratio is lower by the 0.14, the proportion of coarse aggregate is increased by 0.028 at the rate of plus minus 0.01 for every 0.05 change in water cement ratio. Therefore corrected proportion of volume of coarse aggregate for water cement ratio is 0.62 plus 0.0028 is equal to, so we will get the proportion of coarse aggregate is 0.648. So volume of fine aggregate content is 1 minus 0.648. So we will get the volume of fine aggregate content is 0.352. Then last step is mix calculation. So mix calculation as per unit volume of concrete shall be, so total volume is 1 meter cube and volume of entrapped air in wet concrete is 0.01 meter cube. So it is also we have seen. Then volume of cement is equal to mass of cement upon mass specific gravity of cement, we get the 0.13 meter cube of cement. Then volume of water also we have, mass of water is 148. So from specific gravity we can calculate the volume of aggregate of 0.148 meter cube. Then volume of chemical admixture at 1% by mass of cementitious material. So here the mass of chemical admixture is 4.12 and the specific gravity of admixture is 1.145. So after using this relation we get the volume of chemical admixture, which is 0.0036 meter cube. Then volume of all in aggregate. So from starting A to E, this is the relation A minus B minus C plus DE. We can get the volume of all in aggregate, which is 0.6958 meter cube. So from this volume of an aggregate, we can calculate the mass of aggregate, which is G into volume of coarse aggregate multiplied by specific gravity of coarse aggregate into 1000. So from that relation, we can calculate the mass of coarse aggregate, which is coming 1234 kg. Then mass of fine aggregate also calculate by using this volume of an aggregate, which is 648. So basically these are the mixed proportion for the trial number 1, which is cement is 412 kg per meter cube, water is 140 kg meter cube. Then fine aggregate is 648 kg per meter cube, coarse aggregate is 1234 kg per meter cube, chemical admixture is 4.1 kg per meter cube, and free water cementation we have used is 0.36. So this is the trial for number 1. But in this section we have to do the adjustment of water in fine aggregate and coarse aggregate for the dry condition. So for dry condition, the mass of fine aggregate in acidic condition divided by 1 plus water absorption of divided by 100. So mass of fine aggregate is acidic condition is 648 divided by 1 plus water absorption is 1% of fine aggregate is 1. So it is coming 648, which is less than as the we have seen previously, which is 648. Then mass of then we have to do the correction in the coarse aggregate also. So mass of coarse aggregate in acidic condition plus 1 plus water absorption of divided by 100. So we have seen 0.5 water absorption. So after that calculation we will calculate 1228 kg per meter cube. So extra water to be added for absorption of absorption by coarse aggregate fine aggregate, which is we have to subtract the previous mass of aggregate with dry condition, from acidic condition to dry condition. So 6 kg for coarse aggregate and fine aggregate we have seen. So estimated requirement of water added therefore is 6 kg for coarse aggregate and 6 kg for fine aggregate. So 148 plus 6 is 160 kg per meter cube. So this is the final mixed proportion after the adjustment for dry aggregate. This is cement 412 kg per meter cube, water 160 kg per meter cube, fine aggregate 642 kg per meter cube, coarse aggregate is 122 kg per meter cube, and chemical admixture is 412 kg per meter cube for 0.36 water cement ratio. So basically this is the mixed proportion for the concrete without the fly ash. Basically this is standard for the M40 without using the fly ash. Only super fly ash is used for PVC concrete. So final mixed proportion is coming is this. So in next annexure B, we have seen the M40 grade using the fly ash. In previously we have not seen fly ash. Here in this question we are using the fly ash. So previously only the water cement ratio is coming. In that question we have to use the water cementitious ratio. So for grade is M40, in this type of cement is 43 grade, fly ash is IS 383 part 1, maximum nominal size 20 aggregate, 20 mm aggregate, and the condition is severe for reinforced concrete, and workability is 120 mm slump. Method of concrete placing, pumping, a degree of subdivision good, and type of aggregate in this also they are using the crushed aggregate, and maximum cement content OPC is as per IS 456, and chemical admixture also they are using the normal supply side. So these are the some test results for the materials, cement, specific gravity of cement, fly ash, specific gravity of fly ash, and the specific gravity of coarse aggregate and fine aggregate, and chemical admixture which you have using, and coarse aggregate of water absorption is 0.45 for coarse aggregate, and 1% fine aggregate for fine aggregate. So these are the some free moisture for coarse aggregate, which is total moisture content minus the water absorption, which is 2 minus 0.5, which is coming 1.5. And for fine aggregate also free moisture is total moisture content minus water absorption. So 5 minus 1 is 4. So free moisture is for coarse aggregate is 1.5 and fine aggregate is 4. Then this is the sweep analysis for coarse aggregate and the fine aggregate. On the basis of sweep analysis, zone 2 for the fine aggregate is coming as per the table number 9383. Then these are the same step we have used in previous section. Target strength of mix. This is the same relation, FCK dash is equal to FCK 1 plus 1.65x or FCK dash is equal to FCK plus x, whichever higher. So this is the first step. The second step also same, approximate air content 1% is for 20 mm nominal size. Then selection of water cement ratio. So from figure 1, the water cement ratio is required for target strength of 48.25 is 0.36, as we have seen in previous question also this is coming. Then selection of water content, here the slump is 150 mm, so sorry 120 mm. So from table 2 water content is 186 kg for 50 mm slump for 20 mm aggregate, but our slump is 120 mm. So we have to increase every 3% for the every 25 mm slump. So from that we have get the 201.62 kg water content. As we are using supervisor, so based on trial we will reduce the water content up to 23%. So after doing this relation we get the 155 kg water content. Then calculation of cement ratio, cement content. So we have water cement ratio of 0.36 and water contains of 155. So from that relation, water cement ratio, we get the 413 cement content. So to proportion of mix containing fly ash, these are the some steps you have to use. First, decide the percentage of fly ash to be used based on the project requirement of the quality of fly ash. And so when we are using fly ash or other material, we have to increase the cementitious content up to 10%. So our cement content is 431. So when you increase the cement content to 10%, so it is 474.1 kg per meter cube, which is 474, and water content is 155. So upon water cementitious ratio is reduced when we get the water cementitious material, which is 474. So after doing the relation, we get the water cementitious ratio, which is 0.327. So in that question they are using the fly ash of 30%. So after 470, 30% of 474, which is 142. So when we will subtract the 142 from total cementitious content, our cement content is coming, which is 332, which is less as recommended in the IS 456, which is 450, and also it is given 320 kg per meter cube, which is good. Then proportion of the volume of coarse aggregate, in that our water cement ratio is 0.327, and this zone 2 relation is 0.362. So we have to do the interpolation at the rate of 0.01 for every 0.05 change in water cement ratio. So after getting after getting the corrected proportion of volume of coarse aggregate for cementitious ratio is 0.654.6. So basically this is for the volume of coarse aggregate, and after subtracting with 0.59 we get the 0.41 volume of coarse aggregate. So these are the some mix calculation for all the volume of total volume, volume of entrapped air, volume of cement, volume of fly ash, which is mass upon specific fly ash, which is 0.645 meter cube, and volume of water, volume of chemical, volume on all in aggregate. So from previously we have do these things, so according to we have to do the mixed proportion like that, and after that we have to do the adjustment of the on water on fine aggregate and coarse aggregate. So this is the adjustment after getting, which is 748 kg per meter cube for the fine aggregate, and for the coarse aggregate which is 1085 kg. So after subtracting from SGT condition of then mass of wet coarse aggregate, 16 kg for coarse aggregate and 29 kg for fine aggregate is coming. So final requirement is 155 minus 16 minus 25, which is 110 kg per meter cube. So this is for the fly ash content. So in next lecture we will see the next example using the GGBS as a partial replacement of OVC. Thank you.